This is a talk that I gave at the Melbourne Ruby meetup last night, and I'm re-recording it today so I can have a high quality version of both the slides and the audio. I'm going to talk about railway-oriented programming and how it helps us get back on track within the context of a Rails application. Before we get on track, let me get off track for a minute and discuss how long I spend preparing talks. This talk's preparation was interesting, and so let me talk about that for 1 minute. I wanted to create this nice diagram for parts of this talk. I wanted to have a nice username and password, an authenticate merchant flow. It goes to a result. Either the merchant is found or they're not, and then they have to be active before we go down to the success path. If they're not active, we go down to the failure case. However, when I generated this diagram using Claude and tried to put it in my slide template, which has a nice dark blue background, I had this issue where the diagram, well, Claude has no idea that I have a dark blue slide template, and so the background doesn't match up, which is unfortunate. So I thought, in order to share the love around, send a query to Claude, send a query to Google, send a query to ChatGPT, and see who comes up with the best answer. Google was next in the list, so I asked Google, hey Google, how do I do mermaids with a transparent background? And Google gave me exactly the results that the query matches, not the ones that I want. After this, I thought maybe I could just brew install Mermaid and run it locally myself. No, silly, you can't do that. It's not called Mermaid, it's called Mermaid CLI instead. So I ran brew install Mermaid CLI, and you would think that this would give you a command called Mermaid. It doesn't give you a command called Mermaid, it gives you a command called MMDC. And you can run that with the -I option, taking in the mermaid diagram in text form, and you can give that an output of the file that you want. However, this thing doesn't find the correct version of Chrome. That occurs because I only have a version of Chrome installed that's 139, not 131. I guess Mermaid can't keep up. So I ran brew uninstall Mermaid CLI, and I half expected this to tell me, didn't you mean to remove, you idiot? But no, it actually uninstalled Mermaid CLI, as you'd expect. Then after that, I ran npm install -g mermaid.js mermaid CLI, and it allowed me to, or should allow me to install the Mermaid CLI. But that doesn't work because I was running on an unsupported Node version. Node versions change almost as often as Google Chrome versions, and so we run into that. Depending on exactly how cursed my day is, I can work on any version from Node from between 10 up to 22. So knowing this and knowing how to switch between them, I use the Mies tool to do that. I can do Mies use node at 22 and then reinstall the tool, and it finally works. Then I can run mmdc-i merchant mmd and get it to output me a file, and it does exactly that. It outputs me a file, but still without a transparent background, which is unfortunate. I find the option of -b transparent, and that gives me this diagram where you can barely see the lines. I find yet another option and manage to generate a diagram. I still think this looks a bit crap, and at this point I'm cutting my losses and instead going back to what the original diagram was, which is a regular Claude AI generated diagram. This is from mermaidchart.com, and it makes me it's made me now use my slide template as just one with a white background. No dark blue background here. So, railway-oriented programming. Let's get back on track again. It takes me about 2 hours of fiddling around on these tools before I can start working on a talk. And then it takes me about 10 to 20 hours to come up with the idea, to put the slides in some sense of order, and then rehearse them, and then rejigger the slides, come up with some jokes, and then laugh at them like I'm some kind of sicko. And I rejigger these slides so much and so much and so much because we want a narrative, we want flow, we want a solid beginning, a middle, and an end because we're all suckers for the hero's journey. We love a bit of meta storytelling. Railway-oriented programming, to get back fully on track, is a way of programming so that you have two tracks your code goes down. You have either the happy path or the sad path. In this case of merchant authentication, we want to check a few things. We want to see if the merchant exists, if the password is correct, and if they are active. If any of those steps fail, we switch tracks over to the failure case. Yes, this is in essence a graph of a couple of if statements, but bear with me here, I'm getting to the point. Some railway-oriented programming writing will refer to these helpfully as the left and right paths, which I have clearly labeled here on this chart. I prefer either success or failure, or happy or sad, depending on how whimsical I'm feeling. When your grandparents were in high school, there was such a thing called the Rails way. This gave an emphasis on skinny models and fat controllers. Back then, they, and your ancestors, would write code like this, throwing as much business logic into the controller as possible. You would attempt to find the merchant by their username and then determine if they're active and if the token was successful. And depending on the success or not of that, you would then render a particular outcome based on those results. This code looked a bit messy, and so you'd find a nice dumping ground somewhere in the merchant model, somewhere in the first 100 lines of that merchant model. And you'd add the functionality to the models because the models in Rails are the last resort. The code doesn't belong in the controller, it clearly doesn't belong in the view, it's nothing view related, so it doesn't belong in helpers, so therefore it belongs in models. Later on, some Russian hacker attempts to claim a bug bounty against this code, despite your company not having one. You find a blog post that suggests using active support security utils secure compare, and you make that a critical part of your authentication process. You eventually end up staking your company's success on this. Nobody thus far has noticed. After adding Merchant Authenticate, you can now simplify your controller. You can do Merchant Authenticate, taking out half of the business logic because it is now in the model instead. You read a book by an upstart called Sandy Metz and end up refactoring this code to use unless and early returns. This improves the legibility, and you can now read the code like a 3-course meal rather than some sort of code mukbang. You might think that it ends there. If things go well, all of the steps flow down the left-hand side of this chart, and if any step fails, we switch tracks over to the right side, the failure side, and we do not perform any further steps past the one that failed. It doesn't end there though. We can tidy this code up further by moving it into a different directory of our app/operations, and making an operation class within that directory. Rails will still pick it up, just like it was a controller or a model. I call these operations because the name makes more sense to me than transactions and services. Another benefit is that I can spell operations first time each time, and transactions is a word that I mistype, which is kind of funny because I work at a company that processes payments, and transaction is one of our core models. I loathe here to use the word services because this is Ruby and not Java, and I code in a t-shirt and not a suit and tie. This operation code uses dry monads and its result feature. The result feature of dry monads gives us the failure and success methods, which we can use to indicate the outcome of this operation. This has now radically tidied up our code. All we've done is move it out into a separate class. In the controller, you can use this new operation in combination with case and in, which is pattern matching in Ruby. It's been around since December 2020. And you can pattern match either the success or the failure outcome for the operation. This further reduces the code within the controller to something that only cares about calling out to another class and responding based on the outcome. If you want, the operation can now be used in other contexts of your application without copying and pasting the logic everywhere and upsetting Sandy Metz. This shift has one big win. You can test out the authentication logic without having to cover also what the controller is doing. Admittedly, this current example is a little contrived because this is how all talks start out. A simple example to lure you in, and they hit you with a multi-thousand line example later on. Another win, but a smaller one, means that the code that was in our model now has a better home, this new operation class instead. The model, which was already overloaded with responsibilities, now has one fewer responsibility. Instead of this authentication code being split up between the controller and the model, it's now all centralized into one class instead. I really think that models in Rails applications should only contain methods about representing data and then query methods based on that data or different methods to work with that data. Models shouldn't know about the business logic of your applications. That is what this missing piece called operations are for. You'll note here that in the failure cases, I'm returning some strings. Returning strings as error messages from this operation can allow us to display these failure messages back to the users. There's another pattern here that I like doing instead. I like to use symbols to indicate the type of failure that came out of these operations. I can then choose, based on the failure type, which message to display to the user. I can group together specific error messages if I like, and handle the inactive case separately, or we can genericize the error message, matching all three of our cases, keeping it simpler, and just log the failure reason myself. Ultimately, this all means that the controller now only cares about handling the request, passing in those parameters to an operation, and then responding based on the outcome of that operation. We now have a model which knows nothing at all about authentication, and a controller that also knows nothing about authentication. It only knows it can ask something else to perform that operation. Now, I said this example was contrived, and it really is. It's Railway Programming 101. And I warned you that I was about to bring out a bigger example, and this is where I said at Melbourne Ruby and gave them time to run away, but because you're watching this online, you can't leave. I guess you can pause the video here, but keep watching, it's interesting. I'm going to whip out a bigger example. I work at a company called Fat Zebra, and we process about 1 in 5 Australian payments. One thing we let our merchants do is authenticate. The other more important thing that we let them do is transact with credit cards. And you know how that you're not allowed to handle credit card information in your applications? It's because that we do that for you. When we do that, it goes through this create action in our purchases controller. First of all, of course, it hits the merchant authentication code, but then it also hits this 464 line controller action. I've left out the code from this slide from your sanity and mine. This code builds up the purchaser's data and decides if it wants to proceed with the act of making a purchase. The act of making a purchase starts in this 267 line method in the purchase model. The purchaser's model transact method now runs some more validations and other checks before deciding to send the payload to this 360 line method in another application. The short version of why this is in another application is because microservices were the hotness at the time. And in true nature of all microservices, this is now 30,000 lines of code. This code in the purchase method works with the payload, converting it into what I refer to as banklang, and it eventually sends it out into the world, to those banks. All the methods before this then handle the response from those banks in different ways. The method in this second app includes such hits as this, which gives me flashbacks to this advent of code puzzle from the end of 2023. Once the message goes out, it usually goes out to a company like Fiserv, who handles the payload in mysterious ways with a small band of 38,000 employees. Now, I use this example to demonstrate one thing, that railway-oriented programming isn't just for small examples. It could be applied to this code as well. Taking the 10,000 foot view of this code isn't enough, so we board a rocket and we ride it all the way up to the International Space Station and look out the window. When we do, we can see that this code is doing 6 distinct things. It's first of all validating some input, and then it's validating some input and then finding a card by a token, and then steps 3, 4, and 5 are all about fraud. Has the card been blocked by the network? Does the merchant allow cards from that particular country to transact? And step number 5 is that we're going to call out to some fraud services to see if this transaction looks maybe suspicious, and if it is, we'll block it. At steps 2, 3, 4, and 5, the transaction can fail, and the message never reaches the bank network. We could fail at any one of those steps and jump into what I call the sad path or the failure path of our code. If we chart all of this out, we get, with Claude again of course, we get this thing that looks like an octopus with a bit of a limp. At any point of the purchase process, we can bail out early and not run any further checks, which saves us some processing time. We could approach this by refactoring out the whole lot to use the do feature of dry monads. The do feature of dry monads allows us to split up our code into smaller methods, each which return either a success or a failure. When this yield happens and it sees a failure, the call method stops in its tracks and returns that failure immediately out of this method. Nothing else gets run past that point. If we get right to the end and everything has returned a success, we return a purchase object also wrapped in a success. My suggestion Sorry, one second. This isn't what our code looks like at FatZebra. It's what I wish our code looked like. But given this code is so central to what FatZebra does, any single mistake in here would be grounds for immediate dismissal. So developers are rightfully afraid to touch this code in dramatic ways. I use this horribly complex example from our codebase to show two things. We're not perfect, even though I work there, and even a big blob of code like I showed, something nearly 2,000 lines long, could be refactored down into something more elegant, into an operation like this. You have probably got something like this within your own application. Something really, really gnarly that could benefit by applying what I've talked about here today to make it easier for the developers, you and your friends, in the future. My suggestion with that code and with our code is to extract out little parts of that operation and to build smaller operations around those first, then piece it together into a larger operation over time. I'd approach FatZebra's issue by splitting out each of those 6 steps into their own operations and issuing smaller pull requests for each of those one by one. You'll find places like this in your applications where your code is confusingly mixing together things. Maybe you've got some complex code during the sign-up for your app, like this example. This code is really confused about what it does. Is it business logic? Is it handling controller responses? Is it interacting with models or mailers? The answer to all of those questions is yes, it's doing all of that. We can move a lot of this business logic out into its own operation, splitting up each step into its own method. Now, if you think this yield syntax looks a bit weird, I agree with you, and the maintainers of DryRB also agree with you. They've released a new gem to handle this, called Dry Operation. Dry Operation allows us to define operation classes much in the same syntax that I've already covered, but instead of yield, each step is now defined as exactly that, a step. We still have access to the monads and things of success and failure, and each step will return one or the other. Dry Operation also comes with an active record extension, which allows us to wrap our operation into a transaction block, possibly to roll back our DB operations if any of those steps happen to fail. We can also subscribe to failures for these operations, maybe logging when things go wrong. I bring up Dry Operation and railway-oriented programming because would you prefer to look at code like this all day, or would you prefer to look at code like this? I think you know the answer. You'll find places like this in your applications where the code is confusingly mixing things together. And maybe you've got some complex code during the sign up for your application, or maybe you've got something as massive as our transaction flow. I would encourage you to approach redesigning your code using railway-oriented programming and Dry Operation. It will massively simplify your code and make it easier to draw the line between what the framework is doing and what your application is doing. And you don't need to refactor out big chunks at a time. Just build small operations and combine them together as you go. And you'll see it work wonders for your applications. If you want to find more information about Dry Operation, they're over here on GitHub and the documentation site. Thanks for watching the talk.